Good morning. In this video, we will learn about Dijkstra's algorithm. This Dijkstra's algorithm is to find shortest path in the directed weighted graph, positive weighted graph. Okay. Shortest path problem. What is the shortest path problem is finding the shortest path between the two vertices. Let's say here from B to F, the shortest path is from B to A to C, C to E, E to F. So, shortest path between B to F is B to A to C to E and then F. The cost here will be 9, like 3 plus 1 4, 4 plus 4 8, 8 plus 1 9. So it's easy to find the shortest path for a graph that has non-negative weights. But if a graph has a negative weights, then it will be a problem. Okay. So let's see the algorithm. The algorithm is the Dijkstra's algorithm. This solves the single source shortest path problem for a non-negative weighted graph. Okay. Remember non-negative weighted graph. Can you see the weights in between the vertices? The weight of the edges, like from B to A, the weight is 3. B to C, the weight is 5. So, non-negative weighted graph, we are going to use Dijkstra's algorithm to compute the single source shortest path. Okay. In the slide, when I explained the slide, I explained the algorithm. Now I'm going to trace the algorithm for this graph. A sample graph is given here and we are going to find the shortest path using the table as like given in this sheet. For your exams, the graph will be given along with the empty table. So this table will be given in the exams. You are going to trace the algorithm using this, trace the graph using the Dijkstra's algorithm, fill in the table and figure out the resulting path. Okay, so this is the idea. So remember, the graph with the empty table will be given in the exams. So you are just going to fill in the table only. Now let's start the algorithm. So as per the algorithm, it says we will just initialize the distance to the starting vertex as 0. So let's assume we are going to start from vertex B. Okay. So what are we going to do? First step is, so we will be initialize. Let's first fill in the first column. What is the initial values for these vertices? As I'm going to start from B, so what you do is initialize the distance of the starting vertex to 0 and other vertex to like infinity. Okay. So this is the first step we do. That's what you call initial step. So which vertex I'm going to start here? I'm going to start from B. So put the distance 0 for B. Because B to B, I'm not going to travel. I'm in B. So the distance to B is 0 itself. Okay. You understand why it is 0? Then I'm going to do 6 iterations. Why 6 iteration? There are 6 vertices in my graph. 1, 2, 3, 4, 5, 6. So there are 6 iterations in for this algorithm. Okay. So the iterations depends on number of vertices in your graph. Okay, fine. Let's start the first iteration. We have to finalize the cast and the predecessor. For every iteration, finalize the cast, finalize the predecessor. So finalize the cast and predecessor of a vertex, say V, with smallest cast possible. And that another condition that is not already finalized. So two things. We are going to finalize the cast and find the predecessor. When you finalize the cast, it should be small enough. And the second thing, it's not already finalized. Once it's finalized, it's final already. You are not going to calculate the cost again. Recalculation of the cost again, it's not allowed. Fine. So that's the thing we need to do. So let's finalize the cost. Let's first calculate the cost for all the vertices for A and B and C and D and E, F, all the 6 vertices. Later I will finalize the cost. Okay. So what I will do here is, so let's start, because I said the starting vertex is B. So for the first iteration, I'm going to start from B. So let's see, do I have a edge from B to A? See, this is the starting vertex. I will be writing the starting vertex here. So from here to here, is there any vertex? See, from B to A, is there any vertex? Yes. What is the cost? 3. B to B, of course, by the way, we already finalized this one. So you are not going to do anything. So let's shade it. So saying that this vertex B is already finalized. Okay. So the predecessor for the B is 0, because I go to B from where? Predecessor means the previous node. I'm in B, so predecessor is also B. No, it's not predecessor. I'm in B. There is no predecessor. So can I say predecessor none? Putting a dash, that's fine enough. Okay. Now let's see. Starting vertex is B, B to A. Do I have an edge in my graph? B to A? Yes. What is the cost? 3. Now B to C. B to C. Yes, there is a edge and the cost is 5. B to D. B to D. There is no edge, straight edge. So when there is no straight edge, so copy the values, the previous value. B to E. There is no straight edge, copy the previous value. B to F. B to F. When you don't see any direct edge, copy the previous value. This is the previous value, copy it. So I filled it. I filled the cost for that starting vertex B. Now you need to finalize. Finalize means what? You need to identify the minimum value. Okay. Smallest cost. Among the 3 and 5, this is the smallest. I finalize this cost. When you finalize it, you let's shade that entire row, so that I'm not going to recalculate it, because the algorithm says you are not going, it's final already. So you are not going to recalculate. Now you need to find out the predecessor. B to A. You go to A from where? From B. B to A. It comes from B to A. B to A. So this is the predecessor for this A. The cost is 3. This is the meaning. B to A, cost is 3. And I go from B. Okay, predecessor for A is B. See, predecessor is this, I reach A. From B, I reach A. That's the meaning. Okay. Now let's continue the iteration for the next time. So you see that I shaded the first row. For A, I finalized already. For B, it's already 0. So it is the starting vertex. So that column is all, that row is also finalized. Now you need to continue with the second iteration. See, I reach where? B to A. I'm in A. So you finalize what? You finalize the cost for A. So from A, I start. Okay. So this row is already finalized. This row is already finalized. Now concentrate on C, D, E, F. From A to C, do you have any vertex, any edge? Yes. A to C, the cost is 1. A to D, there is no A to D. This is D to A. Okay, fine. When you do not see anything, just okay. So here A to C, it's not that you need to say the edge cost. Remember, in the Dijkstra's algorithm, when you are computing the cost for a node, you need to see the cost of A is what? Just now you finalized. Cost of A is 3. So cost of A plus the edge, weight of the edge to C 1. So 3 plus 1 is 4. Remember, how do I get 4? It's not that A to C only, the edge cast. No. What is the cast just now you finalized for A? 3. What is the weight of this edge? 1. So the cast of A plus the weight of the edge. 3 plus 1, 4. Okay. A to D, I don't have a node from A to D. Copy the previous value. A to E, of course, I do not have any edge. A to F, there is no edge. So copy the previous value. This is the previous value. I just copied it. In that second iteration, this is the minimum cast. This is the one and only cast. So that's the minimum. I told you, whenever you finalize the cast, you shade that row. I'm not going to recalculate that one. A to C, I come from where? I come from A. This is the predecessor. I go to C. So where are you now? C. So that is the node, vertex. I'm going to start now. Okay, fine. Now, this first 3 rows were already finalized. Now let's check C to D. Okay, let me write the cast here. The one I write here is the cast of A, 3. Cast of C is what? 4. Okay, now let's see. Do I have any edge from C to D? C to D, yes, 2. So cast of the node plus the weight of the edge to D. Cast of the node is 4. Weight of the edge is 2. 4 plus 2 is 6. Okay, fine. C to E. C to E, yes, I have. Cast of the node C is 4 and then edge. Weight of the edge is 4. 4 plus 4 is 8. C to F. There is no such edge directed to the F. So copy the previous value like this. Among this, which one is having the minimum cast? This is the minimum cast for D. So C to D. That means the predecessor is C. When you finalize the cast, shade that row. So I'm not going to recalculate that row. Fine. So this is the cast now. So C. So C to D. Okay then. So now I'm going to start from D. Okay. So D to E. D to E. There is no such edge D to E. So copy the previous value. D to F. Yes. Okay. By the way, what is the cast of D6? Let me write it in small letter. So D to F, I have an edge. So how to calculate the cast? See, the cast of D plus the weight of the edge. 6 plus 5, 11. Do you understand how do I get 11? Cast of the edge D plus cast of the vertex D plus the weight of the edge. So 6 plus 5 is 11. Okay, fine. Among these two casts, which one is the smaller? See, in this iteration, I got two casts, 8 and 11. So this is the minimum. You always take the minimum cast. After you select or finalize the cast, shade that entire row. That means you are not going to calculate again. So D to E. So I come from D. So D is the predecessor. So this is, it is not D to E. This is C because it's a cast of the previous. It's not I compute. I just copy the one. So I copy from the previous iteration. Is it? So that is C to E. So predecessor is C to E. Okay. So now I'm going to start from E. See, this is not the cast I compute now. I compute only 11. From where it comes? It comes from the previous iteration. So what is 8? 8 is the cast from C to E. So C is the predecessor. I'm going to E. E is the one I'm going to start now. Okay then. E to F. Do I have any node? Yes, of course. Okay, let me write the cast of E. E is 8, I said. Okay. E to F. E to F, 1. So 8 plus 1, that is 9. The cast is 9. I told you, this row, it's not a row, it's a column. In this column, only one value. So this is the one I'm going to finalize. So you just shade it. I'm not going to recalculate. So what is the cast? This is for the F, which is 9. So now E to F. So predecessor is E. I'm going for the F. So now you start from F. If from F I don't have it because you already finalized all the cast for all the vertices A and B and C and F. So you don't have to do the last iteration. It's final already because it's all shaded. So that means over. So in this way Dijkstra's algorithm works to find out the shortest path. Okay. Now we still have to continue. The result, it's not ending here. Now you need to show me the path in the graph, resulting vertex weighted graph. So put the vertices as like given in the graph. Now based on the your findings, you are going to draw the edges between these vertices. Okay. First, predecessor is B going to A. B to A cast is 3. Okay, B to A cast is 3. You got the idea? So it's not the, don't write it on the top of the edge. You write it near to the vertex. When you write it near the edge, it means to say it is the weight of the edge. It's not the weight, it's the cast of the, whatever you are circling, they are the cast of the vertices. Like the cast of A is 3, cast of B is 0, cast of C is 4. Okay, so you need to write the cast near to the vertex. Fine. So B to A, cast is 3. B to A, you write the edge, draw an edge and write the cast. Then no predecessor to B 0 because B to B is 0. Okay, leave it. And then from A to C, cast is 4. A to C, cast is 4. Fine. C to D, cast is 6. C to D, cast is 6. C to E, cast is 8. C to E, cast is 8. E to F, cast is 9. E to F, cast is 9. See, whenever you are writing the cast, write near to that vertex. 9 should be written near to F. See? 8 near to E. Near to E. 6 near to D. Near to D. Okay. 4 near to C. Can you see that? 0 near to B. It doesn't matter. You don't have to write. But if you want to write it, it's not a big deal. Okay, fine. 3 near to A. So this is the resulting vertex weighted graph based on the Dijkstra's algorithm. Thank you.